with our final part of our lesson on topic electricity. So we come a very long way. Now we come to the end of this topic. So the final topic related to the power and electrical energy, and finally we will gonna calculate the electricity bills for domestic use. So let's see the first question over here. The length of a motorcycle is labeled 12 volts, 50 watts. So explain the meaning of 12 volt, 15 watts. So these are things over here. This is the voltage. This is the power. So if we see these two things together, we call it power rating. So this power rating will always be if that appliances that we use is using electricity. So every electrical appliances must have power rating. Even your smartphone or scientific calculator also have their own power rating. So what it says that if connected to 12 volt power supply, the electrical appliance will produce or release 15 joule of energy per second. So that is what the power rating actually means. So usually the values here, the 12 volt and 15 watt will be different for different version. But for domestic use in our house, usually the voltage gonna be 240 volts and the power gonna be 100 watts or 200 watts or 2500 watts. It depends on the electrical appliance. But basically, what you need to do here in order to answer this type of question, this is very popular one, you need to say that the electrical appliances must connected to the stated value of the power rating for voltage. In this case, it is the 12 volt power supply. If 240 volt, 240 volt, then you have to say or write 240 volt power supply. And the 15 watt here is the power defined as energy per unit of time. The time is 1 second. So we have to restate it in terms of energy, which is 15 joule per 1 second. So this question is very popular and very simple, but usually not many students can answer it very well because they miss some point there and here. So make sure that you must include all the important points in order to get one full mark. Okay, let's see question number B. What is the value of the current flowing through the lamp when it is connected to 12 volt supply? So let's add some more information here. So if the power rating say that 12 volt 15 watt, then what happens if we connected it below than 12 volt? So for example 6 volt, then the power gonna be half than 15, which is 7.5 watt. So that's the meaning of the power rating, actually the ratio, the multipliers for each 1 volt, how many watt it will generate. Okay. So in this case, the question asks for 12 volt power supply, which is equal to the power rating. So the power, the formula is P equal to V over I, V times I. So we need to find current, then P over V. So P here we choose 15 because it's connected to the voltage. So 15 divided by 12, 1 as equal as. So again, this over here equal to VI. At least memorize it and do not confuse others, such as the the length. There are two things that either you can use the formula for power, or you can use the Ohm's law and power. But to derive another formula that has resistance inside it. So IR times I. So I times I is I squared R. Or if I replace I V over R, so V over R over. So these two equations here both calculate power in terms of resistance. This part over here is usually for power loss. So we will talk about very equation of calculate power loss. Okay. So here we have three formula 1, 2, 3 to calculate power. But this formula is used to calculate power that consists resistance. So how much is the resistance of the filament of R equal to V over I, so V is 12 volts, R is 1.25 ampere, they're gonna be how about if we want to use either two? So let's first one. So if the power is I squared R over I squared. So if we plug in that value, I squared is 1.25 squared, it will become 9. So the third one, what is the magnitude of current through this bulb? So basically, this is the power rating, and the voltage supply is 240, which is equal to the voltage level of the power rating. So basically, so again, the formula is P V I is P over V. So P is 60 watt. So let's make that clear. P is 60 watt. P is 240. 60 divided by 240, 0.25 ampere. Number 3, the current and the flow. 240 volt power supply. How much heat released after 5 minutes? So in this case, we don't use power anymore because heat is energy. So we need to define another formula. E equal to P because P equal to E over the thing that we will form for. Then we just rearrange the formula to become like this. And then we know that P also VI. So it becomes VIT. And then we can also derive a formula that consists resistance So as usual, Vi can also be written I square R T. So it becomes I T and V square over R T. V square over R T. So we have three formulas to calculate energy as well as power. In this case, you don't need to use all of it. It's specifically just one. So which one? This one. But current, it has voltage and it has time. But the time here you must convert it into SI unit, which is so let's equation. V is 240 volts. I is here. Time is 5. So our energy gonna be 240 times 10 times 5 times 60, 700,000 joule. Okay. For an electrical energy level, this is the power rating. When the supply with 120 volts, so this is voltage supply. The supply, as we can see, the voltage supply is equal to the rating. So we're gonna take the count there as well when we want to calculate. This is power of heating produced by the. So since you can use ratio formula here, but you can also use logical reasoning. But if you want to make it more official, more can use what we call it ratio formula, right? Regardless of that, you can I current gonna be the same, even though the voltage is different. So P equals to I equals to P. So this is if we use so 1000 watt divided by 40 volt equal to 1240 for 7 here. Then we can use our I here to calculate the new P. So which is 130 volt times 4.1 ampere. So 120 we got 500. Okay. So this is more appropriate, but we can also use ratio earlier. It's look like this. 240 volt over 120 volt equal to 1000 watt over T. 240 divided by 120. So 1000 divided by answer 500 watts. So we still get the same answer. Or you can say that if supply 140 is 1000 watt, but how about if we supply half 140, so you're gonna produce half of 1000 watt, which is 500. So that is the concept of power rating. Okay, basically, if you want to make the current going to be the same regardless of the voltage supply, and then you have to use the value of current to calculate the new power with the new voltage supply. So let's move on to electrical bill, electricity bill for domestic use. So number one, determine how many units are used when 2 bulbs are used 5 hours for 30 days and each level 60 watt 240 volts. So again, unit energy. So specifically the unit for our energy, or we can use the formula first, E equal to PT. So P, because V square over RT or I square RT is only used to define energy in terms of joule. But in this case, for electrical, we define it differently. We just use the terms over here, E equal to P times T. T here must be the unit of kilowatt and T here must be unit of hour. So it will become kilowatt. We must define our parameters, our value of this unit. So we have two. So let's write down the formula first before we calculate. E equal to PT. So we have two bulbs. P is 60 watt, which is 60 divided by 1000. Watt. Time is 5 hours, so okay, we don't need to change that, but we must multiply by 30. So how many? 2 times 60 divided by 1000 times 5 times 30, it will become 18 or 18 units. So make sure that if you want to find how many units or domestic use of electrical bill and for energy, then you must use kWh as well as the cost for the electrical energy. It must in terms of kilowatt hour. But if the question doesn't state that in terms of how many units or how many costs that incur for the electrical use, then you can use the joule, which is have the three formula. E equal to VIT equal to V square over R times T, or E equal to I square R times T. For 5 hours days, find the electrical energy used by the air conditioner. It doesn't state that the units or the cost or something like that, but we assume that air conditioner over here is used for the define the unit for us, which is this is in kilowatt, this is in hours, then that means that we have to find the electrical units, which in terms of kilowatt hour. So E equal to PT, so we have to 5 hours for 30 days. Times that with 30, we got 300 kilowatt hours. If the cost of electricity is 20, so this is the calculation for this question over here. Gladly, we already calculated in terms of kilowatt hour, but if in case you're mistaking it in terms of joule, then you have to convert it into kilowatt hour because the cost of electricity is defined in terms of per hour, the units. For next 900 units, the cost of using the air conditioner within that month. So the cost itself defined in terms of kilowatt hour. So basically we have 300. So the first 100 kilowatt hour is equal to 0.2 times 100. 0.2 times 100, 20 ringgit. Okay, the next, which is 200, because 300, so just left it 100. You must multiply by 25 cents times 200. 25 times 200, 50 ringgit. So total cost is 70 ringgit. Number 3. The table, the following table shows the electrical appliances. calculate the cost. So if you want to calculate the cost, you must have in terms of kilowatt of using the electric appliances by Ahmad's family with 20 days. So the cost is 20 for 100 unit, the first 100, 20% for the next 900. So again, is we are key that is given in terms of table. The data is represented as in terms of table. What we need to do now, we just P W switch. So if you do that, and what to do, we just need to multiply all the numbers here. But this one is in terms of watts. So all of this must be divided by 1000 first. 1000 times 5. So this is an hour, so it's good. So what is that? 1000 times 12, 7.2. And then the below is 5 times 90 divided by 1000 times 90 times 5. Minus 1 times 1, 200 times 0. 0.6 total 7.2 times plus 2.25 plus 0.6. We've got 10.0. So that is the energy per day at 20 days. So our energy is 10.05 kilowatt hour. Calculate if this number is for first loop. 1000 plus 5 times 6, 90 divided by 1000 times 5 plus 1200 divided by 1000 times 0.5 times 20. Yeah, so it's correct. 201 kilowatt hour. 100 kilowatt hour is so 2 times 100. 20. And the next 101 kilowatt hour is 24 cents times 101. So we will get 24 times 101, 24 times 44.20. Okay. So I think that's all for today. Hopefully that you understand how to calculate the electrical energy, electrical power in terms of SI unit. If that doesn't involve cost and only involve power rating, and you also understand which formula or unit that you want to use for calculating the cost of electrical energy, which is in terms of kilowatt hour. Make sure that you convert all the relevant units into the correct unit. So that's all for me for today. Hopefully to see you soon for the next chapter. Thank you.